ma'am.
Good afternoon,
Good
ma'am.
afternoon, ma'am.
Good afternoon. Yeah. So we discussed Boolean algebra in the last theory class, right? And we looked at some problems. I gave you some problems in the presentation um, to solve on your own. And I've told you to memorize the identities, that is the postulates of Boolean algebra, right? So I hope you are onto the task. Today we are going to start with something new. Before that, Nikita Day wants to ask me a question. I can see it in the chat. I'll read it for you. So she says, ma'am, in Boolean algebra questions, do we have to mention the specifies laws at each step? Precisely, yes. So as you might have seen in my PPT, uh, every step, every step that you do, you have to mention the particular postulate that you are using. Okay, you can follow, as I told you, you can follow any method. There may be more than one ways of solving, of optimizing a Boolean expression, but whatever law you are using, you have to mention that. So that means mentioning the name of the law. For instance, we can say De Morgan's law, and then also stating the law within the brackets, okay, at each step. So this is how we uh, simplify the Boolean algebraic expressions. Okay, any other question? Right, you're welcome, Nikita. Right, so we'll proceed on to Carnot maps today. So what is a Carnot map? First of all, why do we need it? Carnot maps are pictorial representations to optimize Boolean expressions again. Okay, so why go in for Carnot maps when we have already seen a technique, that is the Boolean algebra, to solve the Boolean expressions? That is the first question that comes to our mind, right? Why use Carnot maps? So please see, as I just told you, that there are different ways of arriving at an optimized Boolean expression using Boolean algebraic postulates, right? So obviously, some person subjectively might come at a different expression than another person. Okay. And this also amounts to saying that one of the expressions may be more reduced than the other person's expression. Okay. So Carnot maps, in contrast to Boolean algebraic techniques, provide us with a standard technique wherein we always get an optimized expression in the end, the most optimized expression, and everyone doing it correctly, everyone using the Carnot map correctly will get to the same answer. Okay, that is the most optimized expression. So you see, in Boolean algebra, when I solve a question and I'm right, I know that I'm using the right postulates and I'm doing the right thing, but still I'm not very sure when to stop. Okay, have I come to the final reduced expression? That is, you have to, subjectively put yourself through this process time and again to evaluate whether you've come to the final reduced expression or not, or can the Boolean expression be reduced even more further. Okay, whereas with Carnot maps we simply apply the standard technique and we are going to get our final optimized answer. Is this clear?
Yes, ma'am.
So,
Yes.
okay, good, good. So the motivation is clear why we use the Carnot maps, right? Okay, so let me just, thank you, Lakshika. So let me just switch over to my presentation, okay? Okay, I hope you're able to see my screen.
Yes, ma'am.
Yes,
Right.
ma'am.
Yes, ma'am. Yes, ma'am.
Good, thank you. Okay, now what is a K-map? So K-map is a short for Carnot maps. Okay, the maps are named after Maurice Carnot. He was a telecommunications engineer and he developed this technique of drawing Carnot maps at Bell Labs in US in 1953. Okay, while designing telephone switching circuits, he discovered, he developed, he formalized the technique of using a Carnot map. Okay, the Carnot maps are basically an advancement over another diagram, which we know as the Veitch diagrams, which were proposed by Edward Veitch in the year 1952. Okay. Now, a Carnot map or a K-map in short is a pictorial representation of a small number of Boolean variables. So another question that comes to our mind is that why use Boolean algebra then? I just told you that the Carnot map always gives us a final optimized reduced expression. So somebody might like to ask, then why use Boolean algebraic postulates to solve? Yes, the reason is that though Carnot maps are very handy for expressions that involve two, three, or even five Boolean variables, after five Boolean variables, it becomes difficult to handle K-maps. So they are typically used only for expressions involving small number of Boolean variables. Okay, so this is a kind of a disadvantage with the K-maps. Okay, so what is a K-map? Let's see. A K-map is an array of 2 raised to the power of n squares representing all possible combination of values of n binary variables. So if you remember, suppose I say, we have been doing this again and again in the last few classes. So suppose I have one Boolean variable, as we saw in the last class. What are the two unique input combinations that I can have for as input for this Boolean variable? 0 and a 1.
One.
Yes or no?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Right. If we have 2, then 0, 0, 0, 1, 1, 0, 1, 1.
Yes,
Yes.
ma'am.
Yes, ma'am.
And
Yes,
if we
ma'am.
have 3, then 0, 0, 0, 0, 0, 1,
Ma'am,
0, 1,
8.
0 up till 1, 1, 1. Yes.
Yes, ma'am.
So actually, all the input values that you used to see in the truth table, yes or no, all the input values that we list down in a truth table can be represented in a K-map. Okay, so for each value there is a square in the K-map. We'll just see this pictorially in a minute. Okay, what does the K-map do? It provides us a pictorial method. It provides us a pictorial method of grouping together expressions with common factors and therefore eliminating the unwanted variables. Okay, what is meant by this? I'll just go over with you in detail. Is this clear?
Yes,
Yes, ma'am.
ma'am.
Yes,
Yes,
ma'am.
I'll,
ma'am.
I'll just go over these parts with you. Okay, so please see. Okay. Uh, University of Delhi. So I developed some material for computer system architecture Boolean algebra and Carnot maps and some topics I developed for Delhi University. Okay, there is a center ILLL, Institute of Lifelong Learning in University of Delhi. So I have authored a couple of e-lessons there, and I'll take you to one of my e-lessons on Carnot map to show you. I'll be presenting that to you. Can you see the screen
No, ma'am, not yet.
now?
Yes,
Yes,
ma'am.
ma'am.
It's clear.
Right. Okay. So these are some sections which are shared even by digital electronics, So even digital electronics students, they study these things, uh, uh, Boolean algebra, Carnot maps. So my e-lessons were used for both the digital electronics honors students as well as for the BSc honors computer science students. Okay, beta. Okay. Can somebody read this for me? Who will volunteer to
Yes,
read today?
ma'am. I would like to read.
What's your name?
I'm
Yes, ma'am.
Dipali.
You are? Sorry?
Dipali.
Yeah, Dipali. Okay. Okay. Yeah.
This Carnot map from Carnot map.
Yes.
Okay. Simplification of a Boolean expression is important to reduce the number of gates needed to implement the function. This leads to increased reliability, decreased cost of manufacture, and reduced complexity of the equivalent circuit diagram.
Yeah. Just a second, Dipali. So, is this clear to you? This is the goal that we stated earlier when we were talking about Boolean algebra. We discussed this then also, that why should we, after all, simplify Boolean expressions? Yes. So, what are the possible advantages that we gain by simplification of Boolean expressions? We simplify Boolean expressions, which leads to the reduced number of gates, which leads to increased reliability. Why reliability? Because uh, the simpler a circuit design is, it is easier to maintain that, and it is easier to foresee the faults or diagnose the faults once they occur. Okay, a very complex circuit with so many wires is very difficult to maintain. Okay, that is why. Okay, so this leads to increased reliability, decreased cost of manufacture, obviously because lesser number of gates are going to be used, and reduced complexity of the equivalent circuit diagram. Is this clear to everybody?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am. It's clear.
Okay, continue please.
The following three methods can be used for Boolean expression simplification: algebraic simplification, Karnaugh maps, Queenie-McCluskey tables.
Yeah. So
Section
these are the three methods which are traditionally used. The third one is not in your course. Okay. Uh, so yeah, section 1.3. So this talks about the other e-lesson that I developed for Boolean algebra. It presented the application of, you've already seen the application of algebraic rules to reduce the number of terms in the Boolean expression, right? Yeah,
This section elaborates the simplification of Boolean expressions pictorially using the Karnaugh maps. An introduction to the Cuny-McCluskey method can be found in this section. A detailed discussion on the topic is beyond this curriculum.
Okay, right. So the first thing that we are going to see is how to represent a Boolean expression using a Carnot map. But let me first show you how does a two variable Carnot map look like. Please see on your screen. This is how a two variable Carnot map looks like. Okay, so how to place it in perspective, I'll just show you. Now please see. So this is the kind of truth table that you are already exposed to. You already know of truth table of two variables, two
Yes,
Boolean
ma'am.
variables.
Yes, ma'am.
Yes, ma'am.
Yes. So in the corresponding Carnot map, how many rows do I have? I have a row correspond. I have sorry. How many squares do I have? I have a square corresponding to every row in the truth table. Okay, I have a square corresponding to every
Row
Row.
in a truth table.
in the truth table. So how many squares will I have in a two variable Carnot map? I will have
4.
4.
4.
Yeah.
4.
So we always draw a two variable Carnot map like this. Okay. On this axis, on this side, we take the first Boolean variable, let's say A in this case, and here we take B. Okay, here we take B. Okay. Now, for each of these input combinations, we have a corresponding cell. So the first cell will represent the row where A is equal to 0 and B is equal to 0. So A is equal to 0 and B is equal to 0. Can you see this?
Yes,
Yes,
ma'am.
ma'am.
Right.
Ma'am.
So whatever is the output of A0, B0, we write in this cell. We write in this cell. Is this clear?
Yes,
Yes,
ma'am.
ma'am.
Similarly, the second row is A is equal to 0 and B is equal to 1. So A is equal to 0 and B is equal to 1. Is this clear? So A is equal to 0. This is the row corresponding to A is equal to 0. Okay? Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Yes,
ma'am.
ma'am.
And this is the column for B is equal to 1. Okay, so at its intersection, this is A is equal to 0, B is equal to 1. Okay, is this clear? So this
Yes,
is
ma'am.
the
Ma'am.
cell
Yes,
which
ma'am.
is which corresponds to this particular row. Okay, which corresponds to this particular row. Okay, so you see X here, right? Now, next is when A is equal to 1, when A is equal to 1 and B is equal to 0, what will we get? We will get a Y here. Yes?
Yes, ma'am.
Yes, ma'am.
And the final one is when A is equal to 1 and B is also equal to 1, that is Z. Z
Z.
is represented here. Is this clear, beta?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So, yeah, Dipali, can you just
Yes, ma'am.
read this?
Yes, ma'am, sure. Visually, a Karnaugh map can be seen as the spatial arrangement of a truth table. There is one square in the map for every row in the truth table. Figure 3 shows the correspondence between a Karnaugh map and a truth table for a two Boolean variable problem. Uh, Figure
Is this
3.
clear, beta? Is
Yes,
this
ma'am.
clear
Yes,
to
ma'am.
everybody now?
Yes, ma'am.
Yes, ma'am.
Okay. So, uh, this is the general representation of a truth table of a sorry Carnot map of two variables. Just okay. So how many squares did we have? We had four squares. Suppose the name of the variables was x and y. So I dedicate one row to x is equal to 0, another to x is equal to 1, 1, column 2 y is equal to 0 and another column 2 y is equal to 1. Okay, is this clear?
Yes, ma'am.
Yes, ma'am.
So obviously, what would this be? What would be the value here? It would be
0, 0.
x dash x. When x is equal to 0, it means it is
X dash Y
x
dash.
dash y dash or x prime y prime. Any problem?
No, ma'am.
No, ma'am.
Let us look at the next cell. What would this be? This would be x
X dash
prime
Y.
y. Okay. What would this be?
X Y dash.
X y prime. Is this clear?
Yes, ma'am.
And the final one, where x and y both are 1, x and y. Any problem, beta?
No, ma'am.
Anybody?
No, ma'am.
Now please see these terms
Ma'am.
that you see here. Okay, these terms that you see here, they are also known as min terms. What are they known as? They are known as min terms.
Minterms.
What are they known as? They are known as
Midterms.
Minterms.
Midterms.
min terms.
Excuse
Okay,
me, ma'am.
so this is the zeroth min term. Okay, this is the zeroth min term. This is the first min term represented by m0, m1. Then second min term represented by m2 and the third min term represented by m3. Is this okay? I
Yes,
am
ma'am.
going to be talking more about min terms. Just give me a second. Just keep giving me the feedback if what I am speaking is clear to you. More in-depth knowledge about each of these terms, I'm going to let you know. But what I'm speaking, if at that point in time, that much is clear, please keep on giving me the feedback, right? So that I can go on, right? So this is what you see depicted in this alternate representation of a two variable key map. So they have just put M0, M1, M2, M3 here. Is this clear?
Yes, ma'am.
Where M0 is this, M1 is this, and so on and so forth. Is this clear?
Ma'am.
Yes.
Ma'am, Nandini Gupta is having some doubts.
Okay. Please speak up because I am generally referring to the PPT or the PDF file in hand, so I can't see the chat. Okay. Yeah, Nandini is asking.
And can you hear me?
Yeah, now I'm able to hear you, Nandini. Yeah, tell
What
me.
was you were saying y prime and x prime?
Actually, I'm not able to. Just give me a second. Yes, Nandini. Now tell me.
Ma'am, what was that you were saying x prime y prime to the x dash and y dash?
So, beta, this is common. I think we've done it earlier as well. So, if x, see, x can be in, if x is a Boolean variable, it can have two values, 0 and a 1. Okay, when it has 0 value, we represent it as x prime, and when it has 1 value, we represent it as x.
Okay. Thank you, ma'am.
Okay, that is all. Nothing more to it.
Okay, thank you.
Right? Any other doubt to anybody? Please speak up if you have a doubt. Does anybody else have a doubt? Can I
No,
proceed?
No,
ma'am.
ma'am.
Okay.
No, ma'am.
Good. Okay. So let us now see what do we mean by a min term. Formally, let us now formally define what do we mean by a min term. Okay. So now what is a min term? Okay. So a min term is a logical ANDed term. A min term is a logical ANDed term of n input variables in which each input variable must appear in a primed or unprimed form. And what do we mean by this? Please see. I'll just go back to the definition. First, let me explain it to you.
Ma'am, are you not sharing the screen?
Is it not visible to you?
No, ma'am.
No, ma'am.
Okay, let me see. Is it visible to you now?
No, ma'am.
Now?
Yes,
Yes,
ma'am.
ma'am,
Yes,
it's
ma'am.
visible.
Yes, ma'am.
Okay. Please see on your screen, you can see the standard table that we use. Yes or no? This is the truth table for ANDing three Boolean variables A, B, and C. Can you see this?
Yes, ma'am.
Right. So please see each of these terms, okay, 0, 0, 0, 0, 0, 1, 0, 1, 0, up till 1, 1, 1, they actually represent a min term. We can call them as a min term. So how will I read this min term? As I just explained, when the Boolean variable a is 0, we will read it as a dash, right? B dash, C dash. So what does this min term become? This min term, which is the 0th min term, becomes A dash, B dash, C dash. Any problem?
No, ma'am.
No, ma'am.
Okay. And the second min term would be, can you please speak it for me now? A dash, B
A
dash,
dash, B, C, dash,
B, A dash, B
B
dash.
dash, C.
C.
Third one would be A
A
prime,
dash.
B,
B,
C.
C dash.
C dash.
Yes. Okay, and so on, so forth. The last one would be A, B, C.
Ma'am,
Yes or
minterm
no?
means the value of it.
Min term is the name. Min
Okay.
term is the name given to these what are these? These are actually and products. These are and terms now. A is being ANDed with B is being ANDed with C. What is this happening? A dash and B dash and C dash.
Yes, ma'am.
So what is this? This is a product. This is a product term or a and term, a logical and term of the three variables A, B, and C. In some of these terms, sometimes a particular variable is in its primed form, that means A complement or A dash, and in others it is in its unprimed form, that is A. Is this clear?
Yes, ma'am.
For all these variables, these are all called minterms. These are all called minterms. When we take, let's say if we are having a Boolean expression, you can see what is the Boolean expression here. It involves three Boolean variables. Okay. So for this, obviously, you know that there will be how many minterms? 8 minterms, because we list them in our truth table. You have been listing them in a truth table up till now. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So what is each of these minterms? I'm just speaking it today in a formal technical language. Okay. I am not changing what you have been doing. Please see, I am just representing this in another form. What is this? This is A dash B dash C dash. This is A dash B dash C. Is there any problem in this?
No, ma'am.
No, ma'am.
So the only thing that I'm trying to tell you is that all of these terms are called min terms. All of these terms are called
Minterms.
Midterms.
Midterms.
Yes, they are called minterms. So now let us go to the definition of minterm. What is a minterm? You tell me what is a minterm? Just by looking at these, what can you say about the minterms? What will be a minterm? A
Doubt.
minterm is going to be a
Product.
term which is, yes, which will be a product or a logical and of these three Boolean variables which are there in this expression. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Sometimes these Boolean variables will be in their primed form. That means A complement or A dash, whatever you want to call it. And sometimes they will be in their unprimed form. For example, you can see C here, or you can see A here, B here, C here. Yes or no?
Yes, ma'am.
Okay.
Okay, ma'am.
Now the only restriction is that whenever I say that a AND term is a min term, then it must contain all three variables. Okay, suppose the expression f, Boolean expression f, is a three variable Boolean expression. Okay, then my min term should always contain all three terms. If I say, if I write a dash b here somewhere, then that is not a min term for this Boolean expression. Why? Because C is absent. Now C cannot be absent. C has to be present, whether it is present in its primed form or unprimed form. That means whether it is present as a C or a C dash. But it has to be there. No term can be missing. A has to be there. B has to be there. C has to be there. That is the only restriction in a AND term, okay, for a three variable Boolean expression. If all three terms are present, then in whatever form they are present, whether they are present in their primed form or in their unprimed form, I call it as my min term. I call it as my,
Midterm.
obviously, again, let us look at the truth table. We have been saying that a truth table gives us all 8 minterms. So actually the truth table lists all 8 minterms. So in any of these minterms, do you find any of these variables missing?
No, ma'am.
So, and if instead of a 3 variable Boolean expression, this was a 2 variable Boolean expression, I would have said that the min terms must have both the variables, okay, both the variables either in their primed form or in their complemented form, or primed form or unprimed form. Okay, they cannot be absent. Can you have a truth table of two variables which has less than 4 rows? No.
No, ma'am.
Okay, that is why, right? So let us just go over to the definition once again and see now if you understand this. So please read with me. What is a min term? A min term is a logical ANDed term of n input variables. Okay, it is a logical ANDed term of n input variables. तो अगर हमारे पास तीन थे तो 3 input variables in which each input variable must appear, please see, okay, in either the primed form or the unprimed form. Any problem so far?
No, ma'am.
No,
No,
ma'am.
ma'am.
Excuse me, ma'am.
Yes, who is this? Please.
Tisha.
Yeah, Disha.
Ma'am, ma'am, if there is only one Boolean variable,
Hmm.
then will there be any min term?
Yes, x m0, m1. What will be m0 there? It will be x dash. And what will be m1? It will be the first min term m0 will be x dash. The other one will be m1, which is x dash x. These will be the two min terms.
Okay, ma'am.
Right? Any other question? Okay. Now, so I hope this is clear. I hope this is clear that this is now instead of this, suppose instead of this, suppose if I were to write down a term like this or this expression where one of the terms goes missing, then what do we call it? We know we don't call it a min term. Then what is it? It is just a product term. What is it called? It is just called a product term.
Product term.
This is a normal product term, yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. Okay, is this clear? So if any of these terms goes missing, then it what remains is a normal product term. Okay. Now for n Boolean variables, how many min terms will be there? Obviously, since there are 2 raised to the power of n rows, there will be how many min terms? There will be 2 raised to the power of n.
Power n.
Any problem? For 3 variables, we know we have 8 rows in the truth table, and therefore corresponding how many min terms will be there? 8 min terms. And for each min term, we have a cell in the Carnot map. Yes or no? You just saw that.
Yes,
Yes,
ma'am.
Yes,
ma'am.
ma'am.
Yes, ma'am.
So
Yes, ma'am.
how many squares in a 3 variable Carnot map?
8.
8.
8.
How many squares in a 2 variable Carnot map?
4.
4.
4.
4. 2 raised to the
4.
power of 2 is equal to 4. How many squares in a 4 variable Carnot map?
16.
16.
2 raised to
16.
the power of 4 is equal to 16. Is this clear?
Yes,
Yes,
ma'am.
ma'am.
Okay, right. Now, what is the sum of products form? Let me just talk about the sum of products form. Now, what is the sum of products form? So, in general, if I am writing any expression like this, if I am writing any expression of this sort, okay, we see this Boolean expression f is actually a 3 variable expression or not?
Yes, ma'am.
But is all of its terms actually min terms?
No, ma'am.
This is the only one which is a min term. The first two are not min terms because here C is missing, here B is missing. Yes. So I will call this expression f in the form of, I'll call it a SOP form or a sum of products form. What will I call it? I will call
Sum
it
of
a,
product
Sum of product form.
yeah.
form.
Let us now contrast this with, now what you see on the screen, what is this form?
Sum of minterms form.
This is the sum of minterms
Minterms.
form. This is the sum of minterms form. Is this clear?
Yes, ma'am.
Given that this is a Boolean variable, this is a Boolean expression, three variable Boolean expression, this is a sum of minterms form. Any problem here?
No, ma'am.
Everybody to everybody, this is clear?
Yes, ma'am.
Yes, ma'am.
Yes,
Ma'am.
ma'am.
Yes,
Good.
ma'am.
Yes, ma'am.
Is Aromo there? Is Aromo there? She's
She
not
left.
there?
She left.
He just left it.
Yeah, why does she leave the meeting? I don't understand. Does this happen in the other classes as well? Okay. 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 Astha Vishnoi, is this clear, beta?
Yes, ma'am. It's clear. Ma'am, are you not sharing a screen?
I just thought that I'd ask people if if this much is clear to them. Kirti Mondal, is this clear to you, beta?
Yes, ma'am.
Lynette? Lynette, is it clear to you?
It's clear.
Yeah, good, excellent.
Yes,
Mitali?
it's clear, ma'am.
Thank you, Lynette. Thank you for your feedback. Mitali? Mitali?
Excuse me,
Yes,
ma'am.
who's this? Yeah, tell me.
Mastha. Ma'am, have you stopped your
Yes, beta,
sharing
yes. I've
screen?
just stopped sharing my screen. Yeah,
Okay, ma'am.
I've just stopped sharing my screen. I was just trying to uh, see if people have understood. Okay. Ching, is it clear to you? Is it clear to you, beta? Good. Okay. Okay. Excellent. Excellent. Very nice. Very nice. So, should I proceed?
Yeah, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. I hope you find this all this interesting.
Yes, ma'am.
Yeah, ma'am.
Yes, ma'am.
Yes,
Right.
ma'am.
Good. Good. Thanks, Lakshika. Okay, so what we have done today is we have introduced ourselves to what is a Carnot map so far. Okay, how to draw a two variable Carnot map we have seen. Okay, we have seen what is a min term, and we have talked about the sum of min terms form, and also what are product terms as opposed to this. So we have also talked about the sum of min-term form. We have talked about the product terms and the sum of product form. Is this clear so far?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
Right.
ma'am.
Excellent. The next thing that we are going to see is what is a max term. Okay. What is a sum term and what is a product of Next terms form. And what is a product of sums form? Oh,
Ma'am is not there. She left the meeting.
Ma'am, you are not audible.
Okay.
Ishani, is this a 2 hours class?
ये मैम पे डिपेंड करता है वो कितनी देर लेना चाहती है. Ma'am, you're not audible.
can you hear me now?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am.
So students, what happens is generally that if there is a power outage, so it takes a minute or so for the system to switch on to the UPS. Okay, so during that time, the meet goes off, and I have to reconnect the entire system and come back to you. So it generally takes 2-3 minutes. Okay, So, as I told you earlier, that if this happens sometimes, kindly stay tuned in. Okay. So, but I think it is already time. We've exceeded our time today. So, I'll stop here for the day. Please go and revise these concepts when you come for the next class, and we will take it further from here. Okay. I'll just share. Yes, tell
Excuse
me,
me,
who's
ma'am.
this? Yeah, so tell
Ma'am
me.
Astha. Ma'am, in information panel, you have attached two
What?
things.
I'm sorry. Come again.
Ma'am, in information, you have attached two things, that CSA lab and two documents I think you have uploaded. You attached. What is that?
In the meet invite.
Yes, ma'am.
Yeah, I thought actually I did not attach it. The system attached it itself because it was the same invite that we used yesterday. So I used the same meeting invite today. So the yesterday's recording it has attached with it. Okay.
Ma'am, two things they have attached and they're asking your access to grant in second one.
Okay, no
That's why
problem.
I'm
You don't need to go in there. That's the chat. That's the chat that we had yesterday. Okay, even that is recorded. So
okay, ma'am.
that's not a problem, I think. You don't need to go there, right? Uh, I'll just share the attendance with you. That is nothing basically. Since I used the same meeting invite for today that I used yesterday. So it has copied, it has put the yesterday's recording and the yesterday's chat as an attachment automatically. Okay. And it won't let you access unless I give you the proper access permissions. So it is asking you for permission for the chat. Since I've already given you the permission for the recording, I sent you the recording. Yes.
Ma'am, excuse me.
Yes, who's this?
Ma'am Garima. Ma'am, can you just share
Yeah,
the PDF of Karnov map in the classroom?
I will. I will. Yeah.
Okay, thank you,
Okay.
ma'am.
Yeah.
Ma'am, attendance link.
I'm just sending. Request you to wait for a minute. Please mark your attendance, everybody, and then you can leave.
Ma'am, is this for batchman also?